yours is not good. You need to change your name. So the same thing like Robertson, but we change. Is a the curve become this curve. In fact, it's here. It's a lot easier. So we try to do the comparison. The data. This is by Robertson. This is by Raharjo. The same data. So if it comes to number 2, number 3, this is also number 3. So the same interpretation, but better because of the assumption of the density. So we use another one. So that was using BQ. This is using BQ star. So we have even straight line. So better. Look at this. When you have sediment like this, you have SPT. What is the parameter? 0. SPT 0. So SPT is not good for soft soil. You cannot use SPT. You cannot rely on SPT. When you use there is a direct correlation between SPT and the friction for pile. Say, I remember Meyerhoff is 20 M kPa, right? So if M0, it is 0. Just talk with Professor Ramli. And this is no good. So the good thing is if you use the CPT, and this is the same data. So with the CPT, we can still have same thing here, but we have the number, so we can calculate what is the friction. But here is the dip resistance, and that is the compression. The depth resistance is 0.4, U3 is 0.3, so it means that majority of the resistance is by water, not by the grain soil. In fact, I want to repeat this one, but I'm afraid about time. 10 minutes? Okay. Then I will finish this in 10 minutes, and so that we have some time for question and answer. This one is interesting. Nobody care about this, but because there are so many failures in Bandung, I am because I'm still interested in this. So I request one of my PhD students to do the research. What happened? In fact, Bandung soil is not common soil. It is what we call lake deposit or laku stream. It is laku stream. Center is Bandung. The north part of Bandung is mountain, but the south part of Bandung, in fact, middle to south part, are in fact used to be lake. It was lake, so we call it Bandung Lake. Dung is the Sundanese word for lake. So Bandung means large lake. So that is me. So you know, now you come to Bandung, you come to the lake. So that was the lake. In fact, the lake was contributed by one single big river, which is the Citarum River. And at this time, we have the Bandung Wetan and Bandung Kulon. Bandung Wetan means East Lake, Bandung Kulon means West Lake. And this one has been now occupied by the dam, which is the Saguling Dam. But this one is the city. All the city is located here. Now a lot of problem. What is interesting, after some time, the river used to be to the north. River used to go to the north, so the river is Citarum River go to the north. But due to the formation geology, it goes through a cave. This is the cave. The location is called Curug Jombong, but this is how the cave look like. It is in fact limestone. That is the lake. So that is the river. So the water coming out from the river, very good place, very view, nice view. A lot of young people take photograph. Now that is the Bandung city. The Bandung city is surrounded by all mountain. This is all active volcano. Patuha, Malabar, even Gunung Tangkuban Perahu, and also the fault. This is the Lembang fault. So we are located in very close to the fault. Now this is the result. So we collect the data. In fact, it was related to a project. This is a big project. We collect the value of the water content, and the water content is very high as 300%. But below is normal. Okay. over here, this is the void ratio. The void ratio is from 2 to 8, as deep as 42 meters. What does it mean? It means that this is the lacustrine. If it is the lacustrine or the lake deposit, then the lake must be as deep as 42 meters. Do you understand? So we can have, this is the hypothesis become a thesis. The thesis says the Bandung Lake was initially 42 meters. It was only water, soil coming from the erosion. The erosion soil coming down through water. That is why the void ratio is very high. So it tells you between geology and the soil engineering why the void ratio of the Bandung Lake is very high. A lot of problem with the subsoil like this. If you construct a 3-story or 4-story building, your pile should be at least 42 meters. So the cost of the pile is, the cost of the foundation is higher than the cost of the house itself. This is something I want to share because it is interesting. You go back to your office and look at the Casagrande plasticity chart. And that Casagrande plasticity chart gives you only the boundary, the liquid limit is from 0 to 100%, and the plasticity index from 0 to 60%. So that is the Casagrande plasticity chart, which is used for USCS classification, Unified Soil Classification System. But the problem is, our liquid limit is go beyond that. So which line should be used? We don't have the line. Okay, we don't have the line. But if I did the extrapolation, if this is the extrapolation, then this part becomes clay, or between clay and silt, this one becomes silt. But this is the problem. We say silt, but the behavior is clay. So what should you tell this? Should we move? Because this is clay, this is A line, this is A line. So above A line is clay, below A line is silt. So what do you name that? If you name after the USCS, then we call it silt. But the behavior is clay. We put the code for pressure, high pressure. Consolidation takes time, long time. The permeability is clay, not silt. What do you call that? This one have only probably 20 to 30% of clay, and the rest are silt. But the behavior is clay. So what should you name them? According to our understanding, if the silt is dominant, then we call it silt. No, but 30% is give the majority of the influence of the behavior. So that is why should we move the line over here? But this is not there. If you go to United States, there is no such soil. No, they have a very limited amount. But this is because volcanic. A lot of material is from volcanic material coming down to the lake. That is why it is very special case. In fact, this is another story, but I think it's too long. I am going to leave to Dr. Adnan the file. If you are interested, you can copy it from him. Because this is not a long story, but this is very nice story. So three formation. One is peat and organic. 2 is the recent sediment. 3 is the eruption mud. This is the eruption mud, and that eruption mud is also soil. Just to give you idea how the soil look like. This is how the soil look like. How you deal with that? Do you want to take sample? No way. No way. This is between soil and water. This is what we call ultra soft soil. Ultra soft. Strength is less than 6 kPa. It is interesting. In fact, maybe next time I come back for the story, because this is very sad story. 63,000 people have to be evacuated. 14,000 people flooded. Now no longer. It was 2007, but now you cannot see anymore. Everything is gone. Everything is gone. So this is still open for research. Very sadly, unfortunately, the people from Norway do PhD in geology, but none from Indonesia. So when we go to international conference, they talk about this, and we are only listening. Very sad. I said very sad. Why don't we take the chance to learn about this? Because when we learn, nobody believe. Even our own people, they don't believe. Our own people, Indonesian people, don't believe Indonesia. Indonesian people don't believe Indonesia. That's the problem.
Malaysia believe Indonesia.
I hope Malaysian people believe Indonesia. And vice versa. Vice versa. So very sad. What I want to draw your attention is to this, because I said this is very dangerous. All the dike already collapsed. All the dike collapsed. Only the very dike, and the very dike only capacity only 50 million cubic meters. But this is like a volcano. The height of the dike is 11 meter. This one is about 9 meter, but over here is 14 meter. The amount of the mud is 61 million cubic meter. So 11 million cubic meter more than the capacity of the dike. And you see, many people still use the road. If something happened, what happened with this? Yeah, we lost a lot of life. But Indonesian people are so brave. I think the American will not go through this. We go through them. So we are stronger. And very nicely, this is in fact animation. The rate of the settlement was known, so we can do the animation. This will what happened after a few years. In fact, the calculated depth of this one is 60 meter. 60 meter. And that's all the dike that collapsed because it was done on top of the mud. We have a lot of problem with this. Always collapse, and then we have to to speed up the dike, and then we surrender because after all it will overtop. So that is the ring dike, the center dike. It collapsed. So everything is collapsed. No more. We are very brave. See, this one still operating, while this one is working. Very brave. It is more than Superman. But I said in the United States they have Superman. In Indonesia we have Superman. Or Superman. We have Superman, but Superman man, yes. This is man. It is dangerous. Why you done? We need to pump everything. And then the problem is we are solving one problem but creating another problem because a lot of sediment in the Porong River. So Porong River is now polluted, a lot of pollution. This was the last one. We did the measurement, and that is the height. The height over here, it was 21 meter, but now only 14 meter. So this is how the cross section look like. So if take cross section, that is like a volcano. That is why we call it mud volcano. We call it mud volcano. Okay, I think that is the end. This one is similar thing. So this is the situation now. This is very wide, and we are still using this. Okay, just the summary. So as summary, soft soil are normally recent sediment and organic. That is what we understand until now. But also pit. However, there are other products that may be classified as soft soil. In fact, I extend understanding. If you have soil and easily degraded because of water, it is also soft soil. Liquefied sand is also soft soil because the definition soft soil is soil with strength less than 25 kPa. So even sand, liquefied sand less than 25 kPa, it is soft soil. And then if you have tuff, you have water, and then it will be softening less than 25 kPa, it is also soft soil. So that is such as volcanic project or mud eruption. In cases where undisturbed sampling is difficult, then in situ test may be used as advantageous tool to derive the mechanical properties of the subsoil. I hope we can cooperate in this case. Maybe we can use in the area, in your area. Most subsoil create risk during or even after construction. So understanding the behavior of subsoil can reduce the risk, and prediction may be made for future conditions. I think that's it. Thank you very much for your attention.